All right, so here we go, our third exercise. This one is on the addition rule. So we're going to build on what we learned about intersections and unions last week and look at the addition rule. So our learning intention today is to be able to apply the addition rule to find unknown probabilities. To activate your prior knowledge here, I'd like you just to take a sec. Can you think what each of these symbols represent? So pause, take a sec to think about it. And now I'll tell you. So this one is the intersection. This one is union. And this one is the null set, which means an empty set. Not quite the same as zero, as it's not having zero in a set, because zero is a number. It's literally having nothing in the set. And we got a couple of Venn diagrams here. You might see them around some different memes. Something you got to know today is, oh, hang on, I got to exit the drawing somehow. Something you got to know today is cards in a deck. So you can use this as a reference if you need to know what is in a deck of cards. And then here is the questions you're going to do in class. We're going to skip question 1 today. And then you're going to complete something from the progress quiz on paper. Now let's have a look at this new rule. So our addition rule is as follows. The probability of A union B, meaning the probability that something is either A or B, equals probability of A plus probability of B minus the probability of A intersect B. So minus the probability of A and B. You might be thinking, why are we subtracting this intersection? With this thing below, I'm hoping to show you that. So take a sec now just to pause the video, draw these Venn diagrams and shade which region you think each thing is stated, and then try and understand why we're subtracting A intersect B. All right, so have a shot. Now I'm going to show you what it is. So here is A union B. So that means it's in A or it's in B. This one is probability of A. Notice that it includes this middle section that's B as well. This is probability of B. Do you see we've also included that section again? So that's why we have to subtract the intersection, because we count it in A and then we count it again in B. So we don't want to double count that section. Now, if you've got mutually exclusive events, then that means they don't intersect. So there's nothing in common. That's when the intersection is 0. And the probability of the union is just the probability of the first one plus the probability of the second one. An example of mutually exclusive event could be, say we're choosing a card from a deck of cards at random. Maybe choosing a red card is event A, choosing a black card is event B. They're mutually exclusive. There's no intersection there. Maybe rolling a die, maybe numbers 3 or larger is event A, and 2 or less is event B. They're mutually exclusive. You can't have both. Of course, something that is not mutually exclusive could be getting a king and getting a red card from a deck of cards. So it is possible to get a red king. Okay, let's look at our examples for today. Just this one slide of examples today. So we have, hang on, is this still recording? Oh yeah, I think we're good. So we have a card is selected from a standard deck of 52 playing cards. So we've got the 4 suits and there's no jokers. A is the event that the card is a heart, and B is the event that the card is a 4. So first off, we got to find the number of options that satisfy event A. Just remember that N means number and pr means probability. So how many options are there in the sample space for A? So A is the card is a heart. So there are 13 hearts in a deck of cards. You got 1 to 10, and then Jack, Queen, King, 13. All right, number of B. What's B? B is the event that the card is a 4. So there's going to be a 4 of each suit. So the event that the card is a 4, well, there's 4. 4 spades, 4 clubs, 4 diamonds, 4 hearts. All right, now we've got the number of outcomes that are A intersect B. Remember, intersect means and. So it's what is A and B? What is both a heart and a 4? So there's only one, the 4 of hearts. Refer back to that deck of cards if you need to, just to familiarize yourself with them. There are a lot of questions that are based on a deck of cards here in probability. So if you don't know what deck of cards is, it's worth just having a look. Or maybe playing some 13 or something at home to practice. Now, the probability of getting an event A, the card is a heart. So there's 13 hearts in the deck of cards. So the deck is split into 4 suits, spades, clubs, diamonds, hearts. So there's either 13 out of 52 hearts, or you might know that that would be 1/4 of all the suits, of all the cards. Probability of B, probability of getting a 4. So there are 4 4s out of 52. Let's simplify this fraction. I might just divide them both by 2. And do that one more time. If you divided by 4, might have been quicker. So we got 1 in 13 there. That is a 4. Now we've got the probability of A intersect B. So we have our number in the intersection from the above question, which is 1, and then the total number of cards in the deck, 52. Makes sense, right? There's only one 4 of hearts in the deck. Okay. Now we want to practice what we've just learnt. Let's use the addition rule to find the probability of A union B. Remember, union means or. The probability of getting a heart or a 4. So probability of A union B equals probability of A plus probability of B minus probability of A intersect B. Remember, we don't want to double count that middle section of the Venn diagram. So the probability of A A we found earlier was 1/4. Probability of B is over here, 1/13. Oh, and this is going to be nasty. You know what? Let's do this all in 52s. Save us some work. Because we've already got these answers on a common denominator. So let's do probability of A as 13 over 52 plus probability of B, 4 over 52 minus the probability of A intersect B, 1 out of 52. So we've got 17 minus 1, 16 out of 52. And I think we can divide both of those by 4. 52 divided by 4 is 13. 16 divided by 4 is 4. 4 on 13. So your chances of getting either a heart or a 4 are 4 out of 13. So 4 out of 12 would be a third. So it's just under a third of the time you could expect. Now we got to find our last part here. The probability that a card is a heart or not a 4. So remember, not means our complement, the dash. And the probability of a heart, well, we called that event A. And not a 4, well, we called B getting a 4. So not a 4, that means B complement. So we want to find the probability of A union B complement. So applying our formula, that will be the probability of A plus probability of B complement or not B minus probability of A intersect not B. Now, probability of A, we already have. We might have to do some work to find these other ones. So remember, the complements plus that probability must add up to 1, because probability of getting a card that's a 4 and probability of not getting a card that's a 4, getting a card that's not a 4, that's certainty. One or the other. You've got to have one or the other. So that would add up to 1. So we can find out what the probability of not B is, B complement, by doing 1 subtract the probability of B. And we found, so we found that I'm going to write 1 as 52 over 52 just to make the ease of my addition. And probability of B was 4 out of 52. And I'm keeping it on that common denominator of 52 just to make the adding easier later. So 52 minus 4, 38 over 52. So that's the probability of B complement sorted. Now we've got to find this last bit. What is the probability of A intersect not B? What's the probability of getting A and not B? So A is that the card is a heart, and B is that the card is not a 4. So what are the chances, think that through, of getting a card that is a heart and it's not a 4? So if we go back even to our deck of cards, if you look at so we can see here that if we look at all our hearts, there's 1 4. So the number that are not a 4 would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So back to our questions. So because there was only one heart, so there was 12 hearts that were not a 4, the probability of A intersect not B, well, that was 12 out of 52. So let's bring this all together to get our final answer here. So the probability of A union not B, we've got the probability of A from up here, 13 out of 52. We have the probability of B complement, which we worked out down here, 38 out of 52. Subtract probability of A intersect B, which we just found was 12 out of 52. So I might do this in this order. 13 take away 12 is 1, plus 38 is 39 out of 52. That's our final answer. I'll see you in class, and I'll test you guys that you've been listening to this session.